Hello everyone, I'm Ko from May channel. We arrive at final destination, temperature factor that is also very significant controlling intensity of X-ray peak. Roughly speaking, 0 Kelvin, extremely low temperatures, atom hold its position, cannot be vibrate. But with the increasing temperatures, start vibrate, and also we can expect some thermal expansion of solid material. One atom shift away from its original position. That's why a peak of X-ray diffraction will decrease significantly. Okay, let's move on the slide. As I explained, atomic scattering factor Ft at certain temperatures can be formulated as F 0 Kelvin is not okay. Exponential minus m. This is a really general type for describing physical behaviors. M can be defined displacement over dHKL. Interplanar spacing from breakthrough and square. So here we just find the two different very interesting phenomena. The first of all, U, displacement is 0. What is meaning of this one and then? This means temperature will be 0 Kelvin. There is no vibration. That's why this value 1, right? So atomic scattering factor that should be same as F 0 Kelvin. But here, and then temperatures increase. And what happens? If temperature increased, displacements also increased by thermal vibration of atoms. U value is increased. This means M value also increased. M value increased. This means minus M. So exponential minus M, this should be decreased. Inversely proportional. So this value decreased. Now finally, Ft value also decreased. So as I explained before, one atom shift away from its original position. That's why peak should be decreased by thermal vibration. Second, what about that? From the this value, D value. Once again, we just write it down. Black's law, n lambda to the sine theta, right? N is 1, just simple integer. And D can be lambda over 2 the sine theta, right? normally 는 theta value from 0 to 90. This is sufficient. That's why theta value increased. Theta increased, also sine theta also increased. This increased, the value decreased. Inversely proportional decreased. Interplanar spacing. D value. This D value decrease, what they mean? M value increase. M value increase, the same case and then the exponential to minus M. This value also is decreased because it is minus value. So finally, Ft, atomic scattering factor with increased temperature also decrease. Right? So that's why then from the set angle, from the temperature, and leading to somewhat vibration, change in the displacement, and both really contribute to change M value. This M value also increase or decrease, also changing which one? Atomic scattering factors at specific temperature. But here's intensity, integral value, this proportional to temperature, atomic scattering factor square, like a structure factor. So this value can be square. This one 0 is meaningless, and then we just give a 2. So that's why exponential to minus 2m, this value. So we can call this value, this is temperature factor. And you still have some question, and then how can you calculate these temperature factors? It's very difficult. First of all, you need to consider thermal coefficient, certain material, initial, and diameter. So many variables you need to know. That's why normally they just provide some figure and table like this. So you need to know how to interpret this curve. First of all, I will just take the one example of the aluminiums. 자, x-axis sin theta over lambda value is same as x-axis value found in structure factor sin theta over lambda. 자, y-axis value is, yes, this temperature factor exponential to minus 2m. We explained before, so what happened with increasing temperatures and Ft value, atomic scattering factor at a specific temperature decrease, right? That's why you can see decreasing tendency for all material. In same case, there must be some kind of little change, and then so huge steeply decrease, somewhat just roughly decrease depending upon material characteristics. 자, aluminum alloys. That we just calculate some value. Sin theta lambda. There might be, we just calculate from the calculation 0.25. From this one, and that we can lead the some kind of point, and then this one. So the roughly the value temperature factor 0.8. That's all. So you don't need to worry about some huge calculation to derive some final value for the temperature factor. One interesting question here, and then is platinum and Au is gold, and then gold and platinum seems to be someone's really confused, and then platinum is gold and then gold is platinum. No, it's totally different material, different elements. But anyway, both are very, very expensive, and then women really like it. The which one you choose? Yeah, this is some kind of question. Most of people choose Au, gold. What kind of tendency? And then, this one, temperature factor calculation, it decreased significantly. And platinum decreased. That's why from the X-ray diffraction, considering effect of temperature factors, platinum is, how can I say, more precious than the gold. Let's say there's one X-ray diffraction peak. Y value is intensity, as you know. X value 2 theta. Assuming there are specific material have same height, right? Same height. 3 different peak having the same height, same integral value. This is 3 the peak with the same intensity. This normally happen at 0 Kelvin, let's say. What about that? Temperature increase. What kind of curve will be expected in then? First of all, let us draw. Do theta I value. First of all, this is background. We need to define this one. What is this blue line? We can say this is the background. Theta, normally theta value increase. This means, and then they also change in the displacements. So, and noise. Noise also increase. This means the background will increase in this way, right? We can give blue color. This one. Theta increase. This means D value decrease, right? From the black law, D value decrease means M value rather increase significantly. M value increase, this means minus M, this value decrease. So finally, atomic scattering factor temperatures decrease. So the final results in the first peak, this one, and second, this one, and this one. This is the result. So by considering temperature effect or theta effect, and then the curve should be different from what we know. Up to now, we are able to figure out 5 different factors. Let's check it out together. Structure factor as a primary ones, polarization factors, Lorentz factors, multiplicity factor, temperature factor by today's class. In next video clip, I will show you how we can calculate intensity of X-ray peak considering 5 different phenomena.